From the image you can see on your screen right now, you've realized that I finally came to the conclusion that just looking at the FM can was not going to solve the problem. So I took the back off, and it's pretty simple. There are 3 screws that you have to loosen. This guy over here, there's one on the side, there's one on this side, and then actually there's another one underneath that you have to access through a hole down at the bottom from the underside, and the can comes off. All well and good so far. And this is the inside of this RF can, and as you can see, it doesn't seem to be too complex, but the problem with these FM cans is that everything is at very high frequency, or relatively high frequency, so everything makes a difference. The positioning of the wires, the shielding, everything makes a difference to the workings of this guy. And I decided to start doing to this can what I do to the rest of the radio. And just to show it its due respect, I did all the marking in thick green pen. So you can see I started doing all the tracing, checking components. I desoldered a lot of them because some of these components are across coils, so you can't really measure them in circuit. Anyway, to cut a long story short, I took one hell of a long time making sure that all these were correct, that the values were correct, that the wiring was correct. And finally, I went to check that coil, which is the secondary of this first IF transformer, which is actually inside the can. And what I realized was that I was not getting continuity between that point there and ground, which obviously I should. As you can see, this is just a coil through there to ground. No continuity, and that sort of explains everything, because that's the first IF transformer. If I'm not getting the signal coming through there to there, then whatever I'm getting at that point going into the ECH81 is just a sniff of whatever is actually supposed to be across that coil. That was the problem, okay? And just as is to be expected with these things, that was the last bloody coil that I checked. And also, just to make things worse, I remembered a bit of advice that another restorer gave a long time ago in a video I've seen ages ago. A gentleman called, I think his YouTube channel is Joe R. Nunn. One of the things he stressed is, before you go looking for complicated stuff, before you go desoldering complicated components, and these are very complicated to desolder, as I mentioned, inside that confined space, check the continuity of the coils. Get an ohmmeter and check the continuity of the coils. And of all the coils in this bloody can, that would have been the easiest one. In fact, I could have checked that without opening the can, because I could have connected this to that switch inside the radio. That top point there is a switch, and I could have just checked continuity to ground. Anyway, one lives and learns. So the result is, we've got a working FM. All that was, just to make it even more ironic, is that there's nothing wrong with the coil. There was just a bad solder joint at the top end of that, where that connected, the coil connected to that wire that goes back into the switch. Anyway, let me show you. We've got the radio on FM. I've got a short antenna at the back.
Mais uma das músicas obrigatórias de Cian.
Not bad.
Ainda os Primitive Reason, Seven Fingered Friends, e falo-se logo no início desta semana da nova música dos GRAETZ.
See? Got FM back.
Cedo de duas grandes vozes. Shiny Crystal Waters. Estamos a 22 minutos das 4.
So, all because of one little hair thickness wire. And the other thing I've discovered is that the magic eye is actually working. It's pretty dim, but I hope you can see that. There's a lot of reflections in here. As I tune in, there's our signal strength, nearly touching the middle and moving out. There it comes again. So the magic eye is working. I thought it wasn't. It's very dim, as I said. I probably will have to change the supply voltage to that. That's getting the second B+. I might try the trick of connecting the higher B+, the first B+ to that. It tends to give it a bit more life. But yeah, this thing is working. And all I need to do now is to undo the cock-up that I made when I messed up with that coil by mistake. You know, when I was aligning the AM. So I'll have to do an alignment quickly, and I think we're there. Great stuff. Obviously there were still periods of procrastination, and in the middle of those I decided to carry on with the job of getting the faceplate and knobs and everything cleaned up. So here's the first display of that. This thing came out beautifully. All the knobs are in perfect condition. Look at that. They were just black. So it came out brilliantly. Faceplate is in perfect condition. All that was cleaned up very patiently, as usual. As much as I hate to do it, look at that. There's not one little chip out of this thing. It's beautiful. So yeah, that was 2 jobs done. Cleaning the faceplate and knobs and everything else, and then completing or correcting the FM problem. Right, so next, just do an alignment on the FM and sort out the weak signal. I think the mess up that I made with that coil, that one there, is probably going to be the most significant change, but we'll see. But as you can hear from my tone, I'm a lot happier, because FM is my ultimate goal with this radio. It's only got FM, medium wave and long wave. And after this, all I have to do is have a look at the power amp stage and see why we're only getting 1 watt and why we're getting clipping very early on the one side of the waveform. I think I have a clue as to why that's happened, but I'll get this thing set up and we'll check it together. Okay folks, we have some news, we have some progress.
Na Rádio Palmeira e também na Rádio
estou na banana.
We have some progress. The alignment made one hell of a difference. Contrary to what I thought, the alignment of, or the correction of that mess up that I made on that one coil was not the most dramatic effect. I'd messed up that one, I believe, over there. That was not the most dramatic effect. It did have an effect, but strangely enough, I did these two, those two, and then the two inside here. The first IF transformer, really, the 2 coils, one of them made one hell of a difference, and the sensitivity of the radio just went right up, but really a lot. It's almost like the thing was completely detuned. So it leads me to believe that the problem with that coil that we had was actually someone messing with that core that may have touched the wires. You know, these things are very, very fine. Somebody could have put the screwdriver in there and gone haywire with it, and it could have actually messed up the you know, the actual wire of the coil, and so left it detuned and also left it open. So yeah, so our FM is back, which is great, and it sounds very, very good. So I call this restoration, with the exception of one final detail, complete. And that final detail is checking the power amplifier, which was giving us clipping too early. Effectively, it was giving us clipping when it shouldn't. We were only getting 1 watt of clean power out of it, and some people pointed out that's a little too low. But I did notice something. I'm quite accustomed to assuming that these things work on, you know, 5 ohm speakers. And what we have here is something different. We have, according to the schematic here, 3 ohms. So that means if I put a 5.6 ohm speaker here, the impedance that I'm transferring to the primary of that output transformer is double what it should be. And if I put double the impedance in series with that tube, it's damn likely that I'm going to get clipping. Now, 1 ohm makes a hell of a difference. If this thing's supposed to be 3 ohms, and let's say this is supposed to reflect, oh, I don't know, 4K, 5K, 5 kilo ohms, it depends on the winding ratios, then simply by doubling that, I'm getting a huge effect on this, because the way this works is you get the turns ratio, square it, and you multiply that by the speaker impedance, speaker resistance in this case, 3 ohms, and multiply that, and you get the effective impedance of that primary. So what I'm going to do is I'm going to change the resistor combination that I have on the output there, and I'm going to test it again and see what we get before clipping, to see whether that was the main problem. So what I've got here now is I have the usual load resistor, 5.6 ohms, and I put in 200 ohms, or rather 10 ohms in parallel, put those two with these clips in parallel with that. The final resistance that I'm getting is 3.1 ohms. That's near as damn it, close enough to 3 ohms. So let's do the same experiment, put in an audio signal into the pickup input and see what we get. So here we are. We have the signal connected to the pickup input at the back. I've got the volume active, and I'm going to increase the signal level coming in from the signal generator. I've got a 1 kilohertz signal there. Let me give this again, give this max. These are the tone controls. If you recall, they did affect it. All right, so what do we have here? This is already slightly distorted, but it's not clipping. Brilliant. What we're actually seeing here, it's, if you call that clipping, that's the effect of the tube clipping. It's not a sharp clip, as you probably know. It sort of rounds off the corners, giving it all those nice harmonics that people like from tube amps. But what we're getting is it's basically happening on both sides of the wave. If you see that, it's not just on the one. So that means that with a 3 ohm, we've actually got a balanced system, or more balanced. It's slightly higher at the top, starts first at the top and then goes at the bottom. But if we clean that up to there, let's call that pretty clean. What do we have? We've got 6.5 volts peak to peak. We've got 2.37 volts RMS, 2.38. So 2.38 volts RMS. If you square that and you divide it by the resistance of the speaker now, which is 3 ohms, 3.1 ohms, we get 1.9 watts. So 1.9 watts is basically double the power before clipping. Now, I'm sure that we could tweak the biasing of the EL84 a little bit more. The EL84 might actually not be as strong as it could be, because you should get a little bit more than this. But that's pretty good. And believe me, This thing is loud. This is something that people don't quite get when you talk about 1 or 2 watts from a tube amp. You put that on maximum with 1 or 2 watts and you actually fill the house with noise. So it's basically the problem I had here then was that I was getting, I was actually using the wrong speaker resistance, or rather the wrong load resistance to simulate the speaker, because that is more like it. Just check the resistors, they're hardly warm at all. These things are, 10 watts each. It's all being divided between the resistors, so there's no heat really going on there. So our speaker, or rather our output stage, is good. And that sort of wraps up the restoration process, except for the dreaded cabinet. And there's also something else I might do to this before I call it a done deal, but we'll get to that on the next video. So this is it for now. See you soon.